All right, in this video, I want to talk about Z-scores, also known as a Z-score or a standardized score. And this is useful for many reasons. Basically, if we're looking at different types of data and we want to standardize it, so you could use it for test scores, salary, you could use it for age, height, weight, all types of data can be standardized, and then you can compare it more easily. I'll give you some examples here in a moment. All right. So a Z-score is a statistical measure that describes how many standard deviations a data point is from the mean of its distribution. So in a previous video, we looked at central tendencies, the mean, median, and mode. In this Z-score, we're focused on the mean or the average. If we know the average of your data set, then we can use standard deviation to see which participant, which student, whoever it is that you're studying, it has a standard deviation away from the mean. So let's take a look here. This is the formula that you would use if you were doing this longhand. The X is the value you're examining or your data point. Your mean is the data or your average right here is the average of your data. And then this is your standard deviation. So we're looking at your data set. Again, this is the average or the mean. And then the bottom one is standard deviation. All right, so what does this actually mean? A Z-score of 0 means the value is exactly that of the mean. If we have a full data set and we see a mean score of 0, it means it matches the average of the full data set. A positive Z-score means that the value is above the mean, a negative is below the mean. So if we have a Z-score of +2, it means that it's 2 standard deviations above the mean. If it was a -2, that would be 2 standard deviations below the mean. Z-scores help compare data points from different distributions. So in this next example, I'll show you some salary, education, and years of experience. And when we just look at it as raw data, it's not easy to compare. But if we can use the Z-scores, it helps us to make a better comparison between the employees. They're used to understand how unusual or typical a data point is within its distribution. So here we are with our example. We're going to look at salary, education, and years of experience. Let's say we have these 3 different data sets or variables, and you're wanting to compare this for employees of a specific company. Imagine you are comparing Alice, Bob, and Carol, and you want to assess how each employee's salary is impacted by years of experience, years of education, and compare that to their peers. So what we have found in the data set is that the average salary is $60,000, and the standard deviation of the entire data set, we're seeing a $10,000 standard deviation. So they could be 50,000, they could be up to 70,000, but that's standard. The years of education, we notice 16 years of education, so 12 years being a high school graduate, and then these folks have a college degree. They have a standard deviation of 2 years. So some have a bachelor's, some have more than a bachelor's. And then you're seeing that what we'll see in the data set is that some folks have less than 16 years and maybe they make more money. And other people have more than 16 years and maybe they make less money. But that's not consistent across the entire data set. And then we want to look at years of experience because anecdotally, we might think that the longer we work, the more money that we'll make. What we see is in this specific data set is that the average number of years a person is working is 8 years, but we see that some people are working with a standard deviation of 3. So some a little bit less, some a little bit more. Now let's look at this more on a personal level. We have Alice, Bob, and Carol. So Alice is making $82,000 a year. She has 10 years of experience and 18 years of education. We have Bob, who's at $75,000 with 6 years of experience and 14 years of education. So just at a glance, we think, well, the more education we get, the more money we make. In this case, that's played out. We also see the more years of experience we have, the more money we make. That's playing out. I'm going to show you the data set in a minute, though, and that's not always the case. We also see that the least number of years that somebody's working maybe we would think they're making less money, but that's not the case in this situation. Bob only has 6 years, but he's in the middle. He's making more than Carol, but less than Alice. And then we also see that he has the least amount of education. So again, anecdotally, you might think, well, if I don't have enough education, I'm not going to make as much money as everybody else. Sometimes that's the case. Sometimes that's not the case. So to standardize the data so that we can understand this better, we'll use the Z-score. All right. So using the Z-score, Alice has above average scores in salary, experience, and education. She was higher than all the rest with Z-scores of 1.0, 0.67, and 1.0 respectively. Bob is above average in salary and experience, but has an average level of education. Carol has below average scores in all 3 areas. So with that, then we can help to understand how to standardize the data. Basically, we're just looking at how many standard deviations away from the mean it is with our specific data set. So we can only call that what it is with our one specific data set. And we can't generalize that to a larger population or a larger group of people. So let's go ahead and look at this with an Excel spreadsheet. Okay, so in this data set, we have our fake employee ID. We don't know which one would be Bob, Carol, or Alice, but we're just going to assume that somebody in here is named Bob, somebody's named Carol, somebody's named Alice. We have fictitious salaries. All of this is fictitious data, years of experience, and years of education. So to standardize this, we want to use the Z-score. Now, the first step is to find the mean and the standard deviation. The formula is here, average, and then your data set. In this case, I'm just looking at salary. So I'm going to put that over here for you. We want to know the mean for, I'll go ahead and do years of experience here. So this one is salary. This one is years of experience. And we want to have the mean, standard deviation. So the mean we put equals average, and then you just come in and highlight your data. So we have 100 people in this study. Close your parentheses. So notice up here equals average. I'm in column C and hit enter. Now our mean is 8.36. So that's years of experience. We're right around that 8-year mark. Standard deviation, we're going to use the formula STDEV. So equals STDEV, parentheses. Again, this is years of experience. Highlight your data and then close your parentheses. All right, so here we're 4.34 is our standard deviation. That means that people are somewhere between 4 points away from that average. Now, to get your actual Z-score, there's a couple of different ways to do this. I'm going to add some columns. So we want to do the Z-score for education. No, for experience. Here, and I'm going to do it 2 different ways. Because there's 2 different formulas to do it. Okay, so in this case, you'll see that for salary, we're using the specific data set, the specific cell, and then we're also using mean and standard deviation. So we need to have, let's bring that over, equals, we're using years of experience. So I'm going to click on that. And then we want to know the mean, which is 8.36, and let me come back into this just a second. All right, so it's the cell minus the mean divided by standard deviation. So the cell is years of experience minus the mean, divide that by standard deviation, and we have to put our parentheses in here. So there we go. Okay, got it. Now, if we were going to copy that down, notice that we'll get errors. And the reason we get errors is we haven't locked this, so we need to lock it. So let's go ahead and come in here. You'll put a $sign between the cell and the cell number for each of the variables that we want to lock. So mean and standard deviation, we're going to lock that. And then when you carry it down, it should work. Okay, so this is your Z-score for experience. And again, the way we did that was, come in here, we did equals our actual data, divide it by, or I'm sorry, subtract the mean. So equals, in this case, C2, and subtract mean. And then we're going to divide that by, put that in parentheses, divide that by the standard deviation right there. Okay. Now, there is another formula that you can use for this. This is what we did here. So standardize is the formula name. Again, you can go up to this formula bar and use that if you want to, or you can just type it in. So we'll type it in here. Actually, I'm going to use it here. So standardize, because if we do that, it should give you the functions that you need. So the X is your cell. We want years of experience, the mean, and then your standard deviation. There you go. That makes it a little bit easier to see. And then we want to drag that down. Notice again, it's not going to work because we didn't lock those numbers in. So if we come back to your actual formula, you can just put the $sign in front of everything that you need to lock. So we are locking only mean and standard deviation. We don't want to lock column C. All right, and then if you carry it down, that should work. And that's how you get your Z-score. So same thing here with salary. We have the standardized formula. It's using B2. If we double click, you'll see B2. It's also using mean and standard deviation for salary. We can click on that formula bar, see it here. And then if we want to carry it down, put your $sign in front of each of these. And then you can carry it down. There you go. That helps us to standardize it. And then you can easily take a look to see, I'm going to use the data and the filter button. And if I wanted to come in here and see who has a Z-score less than 0, then I can see we have 50 people that are below average with their salary. If I want to see who has a Z-score more than 0, then we also have 50 people with salaries above average. And then if I want to just see, and I don't know, do we have anybody with an actual Z-score of 0? Let's try that again. We can look and see. Oh, select. There we go. And we don't have a flat 0. These are still negatives. We're close. We're close with the 0.02. So we have somebody that's 2 cents above and below the average salary here. But that helps us to compare what we're looking for, especially with this one where we have 100 employees. Okay, so hopefully that helps with Z-score. Let me know if you have any questions.